3 define 1 ampere. So for the definition, 1 ampere here is, you can use let's say you have a conductor with the current flow in the conductor and separated distance 1 meter, and when the current flow in the conductor produce magnetic field B here, and also here we have a magnetic P. So 1 ampere of current through each two parallel conductor of infinite length by separated 1 meter in empty space free of other magnetic field cause of force, because we have a combination magnetic field B and the current flow I, and we have produced force F, or cause of force exactly is equal to 2 exponent minus 7 Newton per meter on each conductor or wire. So this is a definition of 1 ampere. Next question, number B, a moving charge, a proton moving at 7 exponent 6 meter per second along the x-axis here, and enter the region uniform magnetic field B. Magnitude P is 1.8, this is equal to 1.8 Tesla. The direction of the magnetic field is 30 degree with the x-axis. The angle between the x-axis and the angle for the B magnetic field is 30 degree. And the next is, and parallel to the xy, meaning that this is the parallel xy plane as shown in figure, so the same plane here. And number 1, this means the magnitude and direction magnetic force on the proton. So meaning the charge here, the charge, let's say this is a proton P, direction to the along the x-axis, and here we have magnetic field B. Let's say this is magnetic field B, right? So what is the force, magnetic force on the proton? So if you look at the equation, the force when the charge enter the magnetic field B is a QV P sine theta, right? So if you look at the direction here, because if you have the combination of the left hand, okay, left hand, so the finger is the force, the first finger is the direction of the B, right, and the second finger is direction of the V, right, direction of the speed of the proton here. So this is 90 degree. This is for FB, and FV and BV is always 90 degree. So meaning if you use the left hand here, so direction of the force, because B to the direction of the B, and this is direction of the P, so meaning you can use direction of the force is the upward or Z direction. So this is direction. So what happened to the force? Force acts on the charge or proton. So now the value of the Q, magnitude of the Q is proton, this is constant value. The Q is 1.6 exponent minus 19, and the speed of the proton is 7 exponent 6 meter per second, and the magnitude of the magnetic field is 1.8 Tesla, and the angle here is sine 30. So now you can use the calculator, so you can find the value of the force acts on the proton when enter the magnetic field B is equal to 1.0 exponent minus 2 Newton and direction to the z-axis or upward. And the next is if the proton is replaced by the electron, same velocity, compare the magnetic force X on the electron. So if you look at the equation for the force X, the first equation is force on the proton is by the equation QVB sine theta. And then now if you use the electron, this is a Fe, right? So meaning the charge here is an electron charge, and the same V, and the same angle theta. But the charge, the magnitude of the charge proton and the electron is the same value or the same magnitude, 1.6 exponent minus 19 coulomb. So now the force is Fp is equal to Fe, right? But the direction, if you use the electron, meaning this is a negative charge. So the first situation for the proton, you use a left hand. But for the negative of electron, you must use a right hand. So if you use the right hand, direction of the B here, direction of the V here, you can use your thumb direction to the downward, meaning this is a negative Z. This is opposite direction to the first situation. You use the proton compared to the user electron. And the next, number 3, asks you the speed of the proton be affected by the magnetic field. The answer is no, because we have no change of energy, right? Next question, number C. A 4 electric cable carries current 28 ampere from the west. So let's say this is the cable. So direction of the current here from the west to east, right? And the Earth's magnetic field is B is horizontal and directed from south pole to the north pole. Look at if you draw let's say this is let's say the direction of the B, right here, and magnitude is B is 50 micro Tesla. So the question is, what is magnitude and direction of magnetic force on the cable? So meaning if you have a current flow, in the conductive wire and in the magnetic field V, so you have the force X on the cable here. So what is the force here? You can use the equation force is equal to B, the magnetic field, times I, current flow in the cable, and times L, the length of the cable, and sine theta. And the angle here, or theta here, in between the B and I. So direction of the I and B is 90 degrees. So meaning we have B is equal to 50, this is micro, is times 10 power of exponent minus 6. And the current flow, how many ampere? This is 28 ampere. And the length of the cable is 40 meter. And the sine theta, the angle is 90 degree. So sine 90 is equal to 1. So you have a force X on the cable. For the first situation is, okay, use the calculator, this is 0.056, right? So the direction, this is Newton. So what is direction? So you can use the, if the left hand, right? Left hand. So the direction of your thumb is the force, and the first finger is direction of the B. So B is upwards, and the direction of the second finger is direction of the current flow I. So here the direction of the force here is up of the fish, or this is maybe if you look at the two-dimension illustration here, drawing the direction to the upward. And the next, number 2, the magnetic force on the cable is parallel. So meaning the parallel here, direction of the I and B here, the theta is equal to 0. So sine theta is equal to 0 is equal to 0. So meaning time L time I time B, because time 0 the force is equal to 0 when the magnetic force on the cable when the direction of magnetic field, right, and the cable is parallel. So meaning the direction of the B and direction of the current flow is the same direction, I and B is the same direction, so the angle is equal to 0, so the F is equal to 0, right? So answer number 2. That's all. Thank you.